Great. So on Monday, we met for the very first time. We took a look at this picture, how it talked about how it was a piecewise function and how there were some points that were sort of weirder than others, right? And in particular, folks pointed out that at x equals negative 3.5, there was a hole. At x equals 3, there was a hole, and at x equals negative 1, there was also a hole. And that sort of made this graph weirder than some of the other graphs that we've learned about. And we went through and we talked about this idea of what a limit is. And the whole idea of that limit is really in this word here, where we're getting close to a specific value. It's okay if we don't get there, we just care about how close we can get, all right? And so we did two examples that talked about looking at a graph and finding limits from a graph. We talked about some notational things. So in particular, we looked at what this little minus sign means, what this little plus sign means, and what it means when there's no sign at all. And then after that, at the end of class, we were like, okay, well, what happens if we don't have a graph, right? And if we don't have a graph, then our very first strategy was to try substitution, okay? And so substitution just said, we're hoping that this is not a weird point. We're hoping it's a regular point on a graph and that the x value gives you a y value and we're good to go. But then when we took a look at some other cases, we realized that sometimes we would get, when we plugged in the number, we would get 0 divided by 0. And we said that that 0 on the bottom was actually the problem. Okay, that gave us an undefined. And actually, it meant that when we get 0 over 0, we end up with a hole in our graph. Okay. And so we did a couple examples where we were factoring for practice. And I will make a note here that I would suggest that you try this on your own. Okay. Now, when I say try this on your own, that doesn't mean good luck with it. And, you know, if you get it, you get it. And if you don't, oh, well, you're welcome to work on it and either come to office hours and ask me like, hey, this is what I tried. I'm not sure if this is correct. You can send me a message on Discord. You can email me. You can follow up with me or Yithan in any way if you're like, well, I tried this other problem and I'm not sure about it. Okay, so try that on your own, the privacy of your own learning environment. Make sure that that factoring situation is something that you feel really comfortable with, okay, in different contexts. And then at the very end of class, I squeezed in this example right here where we were talking about a different strategy, where we had radicals. And so we were looking at a new strategy where we looked at multiplying by the fancy way of saying 1, right? So we didn't actually change the problem, but we're multiplying by a fancy way of saying 1. And does anyone remember the word that describes the pair of things that sort of look like this? Like square root of x minus 3 times square root of x plus 3.
Complex conjugate.
Ah, very close. Turns out it's just that conjugate part, okay? The complex would be in the situations where we have like a plus bi. So if we happen to have an imaginary number, then we call it a complex conjugate. But a more general term would be that these are called conjugates, okay? Where is a good place to write that? Here, we might describe these as conjugates. Okay, great. All right, so I know we walked through this one example at the very end of class, and I'm wondering, would it be helpful for folks if we did one more like this before we moved on to the third strategy? All right, I see a couple heads nodding yes. Great. All right, so I'm going to say, let's try example 10. Okay, so up here for example 8, we'll leave a little note, try this on your own. Okay, and then we'll take a look at number 10 together. Now, one of the things that I've tried to do in in picking these problems is choosing problems that highlight the calculus that we're doing, but also gives us a really good refresher on some algebra skills that I think are very important to, like, we'll see again, and it will be really helpful if we know how to do this particular algebra trick, okay? And so in example 10, all right, we see this problem, it looks kind of complicated, but as any good mathematician does, we say, let's try the most straightforward way first, which is to plug in the number and see what happens. And so in this case, what value are we plugging in? Great, I see a -1 there. Exactly, right? And that -1 is what we're plugging in because we're saying what happens when x gets close to -1, right? And so I'm going to plug in -1 over 3 minus square root of -1 plus 9. I get -1 over 3 minus square root of 8. Now, just because I know some of us come from different math backgrounds, if you've had me before, you know I'm not super picky about this one thing, but how else might we write square root of 8?
Square root of 2 times square root of 4.
Square root of 2 times square root of 4, exactly. And we could even say square root of 4 is 2, so then we have 2 square root of 2. Okay. Now, I'm going to say this. Most of the time in this class, we're going to be doing a lot of sort of like higher level calculus. It's not going to be as important for me that you know how to simplify this way. Okay, if you know how to do it, that's great, and I don't want to take away from that. But I think as we move further and further on, sometimes it's less about simplifying and more about knowing knowing the particular concept. Okay, and so over here, what is this telling us? -1 over 3 minus 2 root 2. Great. Okay, that's the y value. So this is the y value as x gets really close to -1. It's a weird looking number, but I didn't end up with a 0 over 0. Right? So like this, let's imagine like on the exam, right? And you're like, oh, I see something pretty complicated. Let me try all of this stuff. But it turns out in this particular case, all you had to do was plug in the number, right? So it's worth trying. Just plug in the number first to see whether or not that's going to be useful. Okay. Now, I know we wanted to practice more of something like this, so I'm going to say, let's change question 10. Okay, let's change question 10. Now, you help me out. What could I change this to? So let's call this 10a. Okay. What could I change the number that x is going to if I wanted to practice my own problem and make myself use conjugates?
+1.
Okay, I see some suggestions. I see 1, I see -10. Okay, so if I plug in 1 here, I get 1 on the top and I get square root of 10 on the bottom. I think I still get a number out. And that's okay. If we plug in -10, we're going to get -10 on the top. Ah, but we get like an imaginary situation here. That's interesting. Okay. And if we think though, like a little bit more real, all right, so let's focus on the real situations right now. I see some suggestions in here. Let's try 0. All right, what happens when we plug in 0 into this function? if we plug in 0, all right, we're going to get 0 over 3 minus the square root of 9, which is 0 over 0. And as mathematicians, we're like, okay, that's weird. But from last time, we saw that this means that there's a hole at x equals 0. Okay, so if you are out of practice problems to try, I had a student one semester, and actually I want to say it was summer school. This student did every single problem in the textbook, literally every single problem. And so at some point he sort of ran out of problems, and I was like, well, you can always play this what if game, right? The textbook gives you one value, you're like, all right, I want to make it harder for myself, or I want to make it easier for myself. Right? So we're starting to get to a point where maybe we can start to expand our own practice pool of questions. All right, so we plugged in 0, we realize that that gives us a hole. Now we get to the conjugate part, okay? So I have x over 3 minus the square root of x plus 9. What is it that I want to multiply by to start to change the form of this? Great, okay. We want to find the one with the radical, and we want to write the conjugate of that, which is precisely change that sign and change that sign. All right. Now we've got a fancy way of saying 1. Which means that we have not changed the problem. We're just changing the form so we can see more of what we want. Now we're going to go ahead and multiply. And when we multiply here with our fractions, we're going to multiply straight across. And we're going to get the limit as x approaches 0. All right, now last time, let me see if I can shrink this a little bit so we can get both questions. Oh, I just need to scroll up. Okay, last time I was like, I want you to multiply the top, but leave the bottom alone. And so I'm wondering in this case, if I have this as x times, if I have x times 3 plus square root of x plus 9 over 3 minus square root of x plus 9 times 3 plus square root of x plus 9. What do we want to multiply, and what do we want to be patient with?
Multiply the bottom.
What makes you say the bottom? Because last time we did the numerator, right? So it would be, I would assume someone would think, if I did the numerator last time, I'm always going to do the numerator.
Normally when I see like a positive and a minus sign together, something's going to cancel out.
Right. We chose to multiply the top, not because it was the numerator, but because that's where the conjugates were. Right? And so it's important that we know where are the conjugates, because that is the one we're going to multiply. And the other one, we're just going to be very patient with. We're hoping that something is going to cancel. So we're going to leave this alone. Okay. All right. So we've got our product here, and we're going to go ahead. I didn't leave myself enough space, so let's go ahead and move down to the next line. And we're going to go ahead and leave that numerator the way it is. So we've got x times 3 plus square root of x plus 9 over. All right. So let's multiply this out. When I take these two conjugates and multiply them, what will the first terms multiply to be? All right. It is not a trick, right? And it's 9 is 3 times 3. We get the 9, and I agree that that is our first term. Okay. What happens when I multiply the outer terms? What do I get? Like, what would I write down? If someone said, multiply the outer terms, what would you write down?
3 times the square root of x plus 9.
Exactly. So we would have plus 3 times the square root of x plus 9. What if someone said, all right, well, what do you get when you take the inner terms and multiply them? Yeah, exactly. Same thing. But the minus. And what happens when we multiply the last terms? No more root. Exactly. Right? When we take a square root times the square root of the same thing, we end up with the thing inside the square root, right? Now I'm going to be really picky here and say, do this. We're going to have minus x plus 9. Why is this a minus sign?
Because the positive and the negative become a negative.
Exactly. Negative times positive gives you that negative. Exactly. Now, let's say on an exam, I forget to write these parentheses. What mistake did I just make? Yeah, why is that incorrect though?
Because
Okay, I heard a few different things. Yeah, I didn't distribute that minus sign. I'm going to end up with the wrong sign there, right? And so let's go ahead and put this in here real bold. We want to make sure that we do that, right? Whether we do that just in our brains or we write that down, that's entirely up to you. But think about what you can do to sort of prevent that mistake, okay? All right, let's see what we have. We've got the limit as x approaches 0 with our numerator that we have been oh so patient with, which is great. All right, and in the bottom, let's see what cancels out. This 3 root x plus 9 minus 3x root x plus 9 cancels out. What else cancels out?
the 9s.
And you know what? If you made the same mistake I did and forgot those parentheses, you would end up with like 18 minus x on the bottom, right? And then you'd be like, it's not canceling. And then all of a sudden you start to panic and like, I'm not good at math, but all it was a sign mistake, right? So we end up with, on the denominator, we just have a negative x, right? Because these 9s add to 0. All right. I have x. I have negative x. What do those reduce to? Exactly. These two, when I have the same thing, but a different sign in front of it, it reduces to -1. Okay. And so what do we have? We have, let's start a new line. We've got the limit as x approaches 0 of -1 times 3 plus square root of x plus 9. Now you're welcome to distribute this -1 if you want, but I also know that I'm just trying to plug in 0, right? Like we did all of this so that when we plug in 0, we can see what's happening around the hole, just not at the hole. So I'm just going to go ahead and plug in the number I have. So I have -1, 3 plus square root of 9. And so I end up with an answer of -6. Okay. If you want to distribute that negative sign, fine. I think I find that the deeper I go into this world of math, the more I'm like, I'm going to see if unsimplified, like if I can wait to simplify, I trust myself to do that at the end, but I want to make sure I'm getting the concept of what I need. Okay. Now this -6, what does that represent? in the context of this problem. Oh, sorry, not that one, this problem.
The y.
It does represent the y value, exactly. Y value where?
At x equals 0.
Ooh,
From the last set.
I think I understand what you were saying, Dan, but it's not
So-
actually the y value at x equals 0.
Well, as x approaches 0.
Ah, okay, there we go, right? Such a small difference, but y value when x gets close to 0. But what happens when we're exactly at x equals 0?
There's a hole.
Yeah, there's a hole, right? There's no actual value there. But when we get close to it, we get close to a y value of -6, okay? All right, so I hope this second example was helpful here to just kind of get you in the mode of that decision-making piece, okay? Like, when do we use what? I think is always a very good question to ask ourselves. All right, so we're gonna move on to the fourth and final case that we have here, all right? And so sometimes we factor, sometimes we use conjugates, and sometimes we end up with a bunch of fractions inside other fractions, okay? Well, turns out we start the same way. We plug in our x value, we see if there's a hole or not, and then we go from there, right? Because it could be a not weird point. But in here, for example, 11, if we go ahead and plug in 1, right, we're gonna get 1/2 minus 1/2. Well, oh, that's already gonna give me a 0 in the numerator, but the one I really care about is, am I gonna get a 0 in the denominator? And it turns out we do end up with this 0 over 0. Wow, it's like these questions were sort of picked to be this way, right? So we end up with the 0 over 0, but we persevere through and we say, there's a hole at x equals 1. And so now we need to figure out how we can see what's happening around the hole if we can't see what's happening exactly at the hole, okay? So let's start by reviewing a little bit about fractions. So one thing that we could think about is we have 1 over x plus 1 minus 1/2, and we are dividing it by x minus 1. And so maybe another way of saying that, we could use numbers as an example. What if I had x over 2? What's another way that I could write x over 2?
.5 times x.
We could certainly do 0.5 times x. That would be very valid, right? We could do 0.5 times x. And what I love about what you just said is we could write it sort of the same way that other folks have suggested in the chat, where really we're saying 1/2 times x, okay? If we apply the same idea to here, we'll end up with 1 over x minus 1, right? The x minus 1 is like the 2. And then in parentheses or brackets, we have 1 over x plus 1 minus 1/2. Right? So all I've done so far is just rewrite this, but I've taken sort of the denominator and sort of separated it from the numerator because now I'm just looking at like fractions, like, but not like a fraction inside another fraction. And sometimes that just makes the brain more comfortable, okay? But now let's think about what it means to simplify, say, the inside of it, okay? And yeah, Alexis, what's up?
So I have a question. So is it the same as x like going to 1, or is it 0.5 that she said? Because you wrote underneath the limb that it's going towards 1.
Yep, because we're doing this problem right here.
Yeah, but she said it was going towards 0.5, and is it?
I think we were talking about just sort of a separate example.
Oh,
Okay, so like, just like, how do you write x over 2 is another way. And so someone had said, well, we could write it as 0.5 times x.
okay. Then why did you separate them? Since it's the same problem, like it's the same example as 11.
This is not example 11.
No, I'm talking about below it. Like, how come you put them in brackets instead, even the same problem?
Okay, because I wanted to rewrite it more like this, like 1/2 times x. So this is like our 1/2, and this is like our numerator.
Okay.
Yeah.
I'm kind of confused, but I'll let you finish it through and then see if I
Okay.
get.
Okay. All right. So I think also maybe like if we sort of move a little bit more into the problem, we'll see why separating them is like one possible option. Okay. But as sort of another separate question, if we had 1/2 and we were subtracting 1/3, how would you all approach that?
Make the denominator the same.
Yeah, right. We wouldn't want to just go about our day and be like, great, well, you know, it doesn't matter that the denominators are different. But in fact, though, how would we create a common denominator here?
By using 6. So times 2 times 3 on both up and bottom, and then 2, 2, and then your bottom denominator will remain at 6.
Great. So if I do 3 times 3 here, that's going to make that first denominator 6. And if I do 2 times 2 here, I end up with another denominator of 6, and I get 3 over 6 minus 2 over 6. And how do we simplify that statement?
You now subtract the numerators. So 3 minus 2
Great. And the denominator?
would stay the same.
Perfect. All right. Now, we're going to be doing something similar, right? This idea of if the denominators are different, we better make them the same to help us unpack this. Okay. So we've got our limit as x approaches 1, 1 minus x minus 1. All right. So what do I want to multiply the first fraction by? And what do I want to multiply the second fraction by? So that we get the same denominator. All right, I like that. We've got a 2 over 2. And what about that second fraction? Great. All right, I see what you mean, Kelvin. We've got the x plus 1 over the x plus 1 is what we want to multiply. Wonderful. All right, so now we're going to go ahead and simplify this. Okay, so got the limit as x approaches 1 of 1 over x minus 1. When we combine these first two that we're multiplying, we end up with 2 over 2 times x plus 1. And when we combine the second one, we end up with minus x plus 1 over 2 times x plus 1. All right. Now, before we move to the next line of writing, can someone tell me where someone might go wrong when they're combining these two fractions? Right? What do you think is the most common mistake I see? All right, yeah, that distributing that -1, right? And so maybe if that is a mistake that we've all got different things that we sort of make the same mistake on, if that's us, maybe we put those parentheses around there just to protect ourselves, right? All right, so we get the limit. X approaches 1 over x minus 1, and inside the brackets now, we have 2 minus x minus 1 over 2 times x plus 1. Okay. What does that give us for the numerator inside here? Great, -1, or sorry, negative x plus 1. Okay. Now, in the past, when we've done a bunch of work, at some point we're like, oh, there's things that we can cancel, and then it gets better, right? We haven't reached a point where we've canceled anything yet, or we've been able to reduce anything. But I claim that we actually have something we can reduce right now. I'll give you a moment to kind of look at that. I'd love to hear ideas on what we might be able to cancel, or like what we wish would cancel. All right, I see some good ideas. Love it. Okay. So if we have an x minus 1 here, if this were an x minus 1, life would be great, right? Or if this were a negative x plus 1 and this were a negative x plus 1, that would be great. Or if we could find another x plus 1 somewhere, that would be great, right? Those are all really good options. But I want to sort of bring our attention to a very handy algebra trick, which we sort of saw in this previous problem. Okay, so if I have, how do I write this? If I have x over negative x like I had here, we said that simplified to -1, right? If I have 2 over -2, that's going to give me -1. If I have x plus 1 over negative x plus 1, what do you think this reduces to?
-1.
Exactly. It's like a dressed up version of the things that we saw over here. All right. And so Avi in the chat has really hit the nail on the head in terms of what we're hoping to do here. Okay. So let's take a look at this term right now, negative x plus 1. If I factor a negative out of that, someone tell me what we're left with. Right, so yeah, we end up with what Avi and Dallas had put in the chat, that we have the x minus 1. Wow, that's pretty magical. I factored out a -1, and now look at what we can do. Oops. x minus 1, and x minus 1. Now they reduce. And what we end up with is the limit as x approaches 1 of -1 over 2x plus 1. If you're able to cancel things, like you've done maybe common denominators, or you've done the conjugates, and you get to a point where you're able to cancel something, excuse me, that is a great time to be like, let me try plugging back in that number that I was curious about. Okay. And so that's why at this point, I'm going to say, let's try plugging in 1 again and see what happens. So we get -1 over 2 times 1 plus 1, which gives us -1/4. Anyone here ever hit a pothole while you're driving? Yeah, right. I feel like it's usually like after there's some rain here and just the roads are not built for that. So then like chunks of the road come out and you hit this pothole, right? But what would be really nice would be like if those could be patched up, right? If they were patched up, everyone would have a smoother driving experience. And so all of this algebra is really doing that. We're patching up the hole. We're saying, what if this hole wasn't there? Well, then our life would be much easier. We could just plug in the number and get the value that should be there. Okay. So if you want to think about it like that, you realize there's a pothole, you stop your vehicle, you get out, you patch up that pothole with, I don't know, maybe you carry asphalt in the back of your car or something, right? You patch that up, and now look at how easy it was to get to that answer. Okay. All right, so fractions. I know that fractions can be scary, but I wanted to give us sort of one way to think about how we could deal with fractions and maybe make them less scary. Now, I think it was Alexis, to your point, you don't have to split them into 2 pieces like that. I just find that sometimes when I'm working with like a fraction on top of another fraction, I get confused like where the middle fraction line is. And so this is a trick to kind of help us manage that a little bit better. Okay, but there are certainly other ways to do these kinds of problems. I don't want us to think this is like the one and only way. All right. But I would like to, let's see, would we like to do example 12 or would we like to do example 13? What are we thinking?
So I have a question though.
Of course, what's up?
A common mistake that I made from example 11, I tried it on my own from a YouTube. Am I able to take the top and flip it by the reciprocal and then times it by 1 over x minus 1? Because then the denominator would just be 1.
Are you saying like take
Like just the top piece, like
just
a
take
1,
this?
yeah, and then like flip it and then times it by 1.
No.
Okay.
Yeah, that's sort of too many flippings. And so one thing I would suggest is like keep that numerator. If you can make it to a single fraction, there's actually a different way that you can handle that.
Okay.
Okay.
Yeah. Thank you.
Of course. And so actually, I think that it looks like folks are saying example 13, which is great. And then yes, let's do it a different way, right? Because there's always more than one method to the madness here. And so let's try 13. Let's try it in a slightly different way and see what happens. But I think that might also answer your question, Enrique, about like how to manage that. All right, so we look at this problem. This is the problem on an exam or a quiz or whatever. And you're like, ooh, first thing, plug in that number and just make sure that you're not going to do more work than you need to. Right? But as again, these problems were, carefully chosen to be examples of things that cause issues, right? We realize that we have a hole at x equals 4. And so now we need to do some work to patch that up. And so we copy down this problem again. And we're not going to approach it the same way we did last time, but instead I'm going to make this like fraction line aggressively large. And we're going to have 1 over square root of x minus 1 over 2. All right. And so we are going to go ahead and make the numerator into a single fraction right now, because when we have a fraction over a fraction, that actually makes our lives a lot easier. Okay. So really what we're trying to do is to make it look like something like this. If I had a over b, that's a single fraction, and I divided it by another fraction, I think this is a rule that maybe we know, right? How would I proceed here? If I have a fraction and when divided by another fraction?
You would flip the bottom to make it a multiply, right?
Good, good. So I would have a over b times d over c, right? And then, because I'm multiplying fractions, I'm going to multiply straight across, and I'm going to get a d over b c, right? So that's the trick we're going to use to help us with this slightly different way of looking at it. And so in order to use this trick, I need the numerator to be a single fraction. And so let's do that. What would I multiply the first fraction by? And what would I multiply the second fraction by? All right, let's get that set up.
The first one by the square root of x.
You want to multiply this one by the square root of x?
Yeah.
Ah, okay.
both of
So,
them.
well, so we want to make sure that we get the same denominator over here. So this one already has a square root of x. The other one has a denominator of 2. So if I want to make sure they have the same denominator, if I multiply a 2 here, this is going to give me a 2 square root of x. What would I need to multiply this one by?
That one
Right.
by the square. Yeah, 2.
Yeah, this one we're going to multiply by the square root of x, right? So it's almost like you're trying to multiply by the one it's missing to get it in there. And then we don't want to change the problem. So fancy way of saying 1 is 2 over 2. A fancier way of saying 1 is square root of x over square root of x. Okay. And now we're going to go ahead and keep chugging along to combine those fractions. All right, and so we end up with denominator of 2 square root of x. And the numerator here is just going to be 2 minus the square root of x. Okay. Now I didn't write as many steps as I did in the previous problem, so I just want to pause for a moment. How are we feeling about what happened in the numerator here? Okay. All right. So now I have.
In example 11, could we have just done that instead of doing all those extra steps? Because I was thinking that as we're doing it, I'm like, why are we doing so much? We could just combine it right there. Or are you just trying to show us the distribution part?
You can definitely do this. You would end up with this.
Yeah, just that part.
Divided by that, right? That would still be okay.
All right.
Yeah.
Thank you.
Okay. Now, remember, we want to have a fraction divided by another fraction. Right now, we have a fraction on the top, but I don't really have a fraction on the bottom. What is the easiest way that I can make the denominator into a fraction? Yeah, we could just divide it by 1. And so I want to be really careful here that we are putting a 1 underneath that x minus 4. Okay. Well, now I have a fraction over a fraction. Now I can do this, right? So we end up with the limit as x approaches 4. And so I have the first fraction over the second, or times, and I have to do the reciprocal of the other one, get 1 over x minus. Okay. If I wanted to write this as a single fraction, great. Okay. You know, the funny thing is, this is the way I like to do it, honestly. And then a few years ago, I had a class that was like, they did not like that way. So we started doing it this way. And they're like, oh, yeah, that's way better. I feel like every group is so different. But I'm really glad that you folks asked to see it in a different way, because I think at least this way, people have a choice, right? You can choose which one works better for you. And I really appreciate that. All right. So we've done all of this work, but we haven't gotten to a point where anything cancels out, right? So we're not done patching in that pothole yet. But you know what this does look like right now? This question right here. Well, this 2 minus square root of x, that sure looks like questions that we saw earlier, right? Where we had like 3 minus the square root of x plus 9, or from yesterday, that square root of x minus 3, right? And so at this point, we haven't been able to make anything cancel. So we got to pull out of our bag of tricks. What do we do when we see radicals? And that, my friends, is where we are going to use conjugates for this problem as well. All right. So what should I multiply this by?
2 plus square root of x.
Bingo. And, whoa, are we going to multiply the numerator or leave it alone? All right, we have one vote that we're going to leave the numerator alone. We have one vote for multiply. Oh, I like this, competing opinions. Oh, all right, I see a few more multiplying. Okay, so folks who are so like, yes, we should multiply. Why do we want to multiply?
Those are the conjugates.
Exactly. And you know what? I bet it's going to help us get rid of this. Okay. So we are indeed going to multiply these, and we will be very patient and leave this denominator alone because we're hoping something will cancel. So we have the limit as x approaches 4 of, I'm going to write out this gross denominator first. And I'm going to be really thankful that I don't need to reduce anything yet or multiply anything out, right? All right, what do we get when we multiply out the numerator? Yep, we get 4 from the 2 and the 2. The outer terms and the inner terms are going to actually reduce to 0. And then last but not least, we have negative square root of x plus square root of x, which is negative x. Or yeah. Okay. Well, this one also doesn't perfectly match up, but exactly, Kelvin, right? We see x minus 4, we see 4 minus x. They look so similar to each other. And if we factor out that -1, now we can see the cancellation here. And now we're like, okay, now let's try plugging in that number again. We're going to plug in 4. I get 2 square root of 4, 2 plus square root of 4, which is -1/16. Yeah, -1/16. Right, so great question to pick because it actually blended a bunch of different strategies. Now, I would say this, right? Like, as we're sort of moving through notes and sort of thinking, okay, or we have a test coming up in a few weeks, and like, what are these tests going to feel like? I like to make sure that we have situations where we are stretching ourselves. And I would say that 13 is a really good stretch level problem, right? If you can sit and confidently do this on your own, you've actually practiced in one problem how to deal with the fractions, how to deal with the conjugates, a little algebra trick to get the answer. So you've actually practiced like 3 different problems in one problem, which is awesome. Okay. I would say something like this would probably be a little bit above the level I would expect on like an individual exam, right? Because there's like things like time pressure and like test anxiety and things like that. And what I'm really more looking for is like, I would say something like example 11, that's a little bit more straightforward in that I can see that you know how to combine fractions, right? And that you're able to get to that answer, okay? Dallas, I see a great question. So for these, square root isn't plus minus. It is not in this case because we are looking at, like in this case, we definitely have a plus here. But if there's no symbols in there, then we're assuming that it's going to be positive. It's more when we take like a square root of, and we're trying to solve for a variable. Because we don't know what the variable is, it might have a positive value and a negative value. Does that make more sense, Dallas? Okay, yeah. So if we know what the number is, we just kind of go with it. If we're not sure, it could be one of 2 things. We want to show that we know it could be one of 2 things. Okay. All right. So then for example 12, again, I will leave a try this on your own, right? And I think example 12 should be more in line with example 11, so more of like an appropriate test level question, if you will, than number 13, okay? All right.
On your example, do you like specify use substitution and use radical, or you just want us to look at the problem and see how we would approach it?
It is the second way, and I'm so glad that you asked that because I think there are definitely cases where folks sort of study like, oh, if she tells me to use this method, then I know how to do it. But as we're having these conversations in lecture, like I try and point out the decision making because I do want us to be able to make our own decisions, okay? All right, so I'm gonna stop this recording here.